students, welcome to Moodle class. First, first chapter 1, Introduction to MOS Transistor. MOS transistor is nothing but metal oxide semiconductor transistor. There are two types of MOS transistor: P-type MOS transistor, N-type MOS transistor. Here PMOS having a substrate of N-type substrate, NMOS transistor having a substrate of P-type substrate. There are three terminals: source, gate, drain. Gate is the controlled electrode element, the conduction between source to gate and gate to drain. It is the MOS transistor. Next, we see the CMOS logic. CMOS logic is the combination of PMOS transistor and NMOS transistor. Here CMOS logic basic element is the inverter. Before that, we discuss the PMOS NMOS transistors basic material, basic characteristics. First one is threshold voltage. Threshold voltage is nothing but the maximum current occur, that is the conduction between source to drain and gate to drain. Here it is the type of diode cut-in voltage. Minimum threshold voltage only the transistor will conduct. Below that the transistor will not conduct. It is the threshold voltage. Threshold voltage equal to pi ms minus 2 pi f minus qb divided by cox minus qss by cox minus ki by cox. Here the work function difference, depletion layer charge, surface charge, implants are the elements, and also Vt equal to Vto plus psi into root of minus 2 pi f plus Psb minus root of 2 pi f. Here gamma is the body effect coefficient. Gamma equal to 2q epsilon Si Na root of divided by cox. Cox is the oxide capacitance. Here epsilon Si is the charge in material. Next, current voltage relations. Current voltage relations. Here linear region, saturation region and cutoff region. In cutoff region there is no conduction. In linear region, that is VDS equal to 0. In linear region, VDS is less than or equal to VGS minus VT. VT is the threshold voltage. In saturation region, VDS is greater than or equal to VGS minus VT. Here lambda is the channel length modulation. Next, in velocity saturation, the graph is drawn between VDS in voltage and current IDS in milliamps. Like that, the velocity saturation is draw. It is the non-ideal IV characteristics of NMOS transistor. Next, MOS transistor as a switch. Here we see N-channel transistor, P-channel transistor, and terminals gate, drain source, gate, drain source. N-channel transistor only conduct 1 voltage will be in gate terminal. In gate terminal 1 voltage occur, the NMOS transistor is on. Here 0 voltage is applied means the transistor is off. In P-channel transistor it is vice versa, that is 1 occur in gate, PMOS transistor off, 0 occur in gate, the transistor is on. Here P-channel transistor and N-channel transistor we see, and CMOS inverter. CMOS inverter is the combination of PMOS transistor and NMOS transistor. It is nothing but the inverter, that is inverter gate, complementation gate. Here A input is 0 means output is 1. A input is 1 means output is 0. It is the CMOS inverter. Here POS transistor. In POS transistor, like that NMOS transistor and PMOS transistor. In NMOS transistor, already seen which voltage we give the input, the transistor switch is closed or not. Like that POS transistor is occur. Next, in CMOS logic. In CMOS logic, PMOS and NMOS are combinationally used. That is, in here two PMOS transistor in parallel and NMOS transistor in series, the gate will be act as a NAND gate, NAND function of we get. And also two PMOS transistor is in series and NMOS transistor in parallel, we get NOR function. That is, we see two input NAND gate, two input NOR gate, and truth table we are also seeing here. Like that we can use transmission gate and POS transistor and function implementation. Example, if f equal to a bar b plus c into d, like that function will be drawn, means we can use this logic. Next, here we can see layout design rule, gate layout stick diagrams. Layout design rules, we can known about which color will be used in PMOS transistor, in NMOS transistor. Already we can see that the tabular column and given correct color will be used. In gate layout diagram, the layout diagram is the bar diagram is the bar diagram, and stick diagram is the lightly stick like diagram will be we can choose. Already we can see NOR gate, NAND gate, inverter, all the diagrams will be seen. Here we can see typical CMOS layout rules. N will how much size, P will how much size, and the different distance between diffusions, and the distance between N diffusion, P diffusion, N diffusion we can see. And also poly between N will, P diffusion, like that. Here the diagram fully explained about typical CMOS layout rules and the distance which lambda we can use. In MOS diagram, CMOS design diagram, the lambda rules can be used. There are two rules, lambda rules and micron rules. Here we can discuss about lambda rules only. Next, and also in MOS transistor, long channel IV characteristics. Long channel IV characteristics, we already seen about three transistor biasing conditions, cutoff condition, and saturation, non-saturation. Three regions are shown. Already we discussed about the IV characteristics of MOS transistor. With derivation and diagram we can explain about in here the three regions. Next, CV characteristics. There are three models are there: MOS diffusion capacitance, total diffusion capacitance, and capacitance of the transistors. There are three regions. Here the CV characteristics means capacitance voltage characteristics. IV characteristics means current voltage characteristics. We can already discuss about. Here non-ideal IV effects, total 9 or 10 effects are there. There are already discussed about mobility degradation, channel length modulation, gate tunneling, like that characteristics are discussed about in non-ideal IV characteristics. DC transfer characteristics. Next, here in DC transfer characteristics we can discuss about CMOS inverter, complementary metal oxide transistor, and CMOS inverter characteristics. We can discuss about CMOS regions, and regions we can discuss about what is the voltage, what is the region there are the regions we discuss about the diagram of CMOS inverter characteristics. It is the DC transfer characteristics, and also we can discuss about DC transfer characteristics, DC direct current transfer characteristics. Here we discuss about DC transfer characteristics modelings, like that beta ratio effect, and also the effects of DC transfer characteristics. Next, RC delay model. In RC delay model, delay where the delays are occur. Delay models occur about what the characteristics. Next, Elmore delay model. Elmore delay model, we can get 2-mark question, important question, and the Elmore delay model definition or discuss about already. In linear delay model, RC delay model, Elmore delay model, linear delay model is the delay model characteristics. We can already discuss about that characteristics. Logical effort is the input capacitance of the gate divided by inverter capacitance. It is the logical effort differently get about inverter, NMOS, NAND gate, NOR gate we can get. Parasitic delay is the delay, the parasitic delay gate total diffusion capacitance and inverter capacitance of the input capacitance and node connected to the output node connected to the device is the total capacitance is the parasitic delay. In delay in a logic gate, we can get type of delays. We can get FG logical effort, parasitic delay, electrical effort, path effort, like that. We can example already discussed. We can get here the inverter under inverter logic, how we can get the diagrams are seeing implementing an multiplexer A bar S plus B into S, like that. Multiplexer we can get scaling, in scaling, inverter scaling, device scaling, like that. Scaling is also an important question. We can discuss about introduction to MOS transistor. The important questions are inverter, POS transistor, transmission gate, layout design rule, gate layouts, stick diagram, IV channel characteristics, CV characteristics, non-ideal IV effects. Non-ideal IV effects are separately asked about in 2-mark questions. Transfer characteristics, DC transfer characteristics, RC delay model, Elmore delay model, 2-mark question and 8-mark questions. Linear delay model, logical effort, 2-mark question. Parasitic delay, 2-mark question. Delay in a logic gate, 6-mark, 7-mark questions. Scaling also a important question. They are also an important question here, like that. In MOS transistor, the questions are prepared. Thank you.